Abdullah DWIKAT, Computer Engineering, and today I am presenting my graduation project with the title Dental Anomaly Detection through Biomedical X-rays Deep Learning Approach, supervised by Professor Dr. Rafat Aydin and Professor Dr. Dilar Arslan. So in the beginning, I want to explain what are the types of the dental anomalies that I have used in this project. The types of the abnormalities that I have used is the impacted tooth, fillings, implant, root canal, extraction, and crowns. So firstly, what the current problem or the issue of the project in general that it solved is that we are using currently the manual interpretation in the dentistry department, which the manual interpretation has time-consuming and inefficiency, human error as well, and accessibility issues. So the solution, why do we automate this process? Why do we automate the process of detecting the abnormalities? We automate it in order to have a faster and cheaper diagnosis, to let the dentists focus on treatment instead of focusing on diagnostic, scalable that it can screen thousands of X-rays per day, and more accurate as the model, for example, achieved 95% accuracy. So the research purpose in general is to develop an AI system, artificial intelligence system, that is able to reduce the errors of diagnostics and to give a faster screening, as of course the machine are faster than human beings. The technology that I have used during this project is the YOLO V8, You Only Look Once, version 8 model, which is developed by Ultralytics company. It's a pre-trained deep learning model. And I have used Python, specifically Jupyter notebooks, in order to apply the resizing of the images and the Clache image processing enhancement, which I will talk later in detail about it. And I have used Flask to connect the user interface that I have built with the model itself. And for the user interface, I have used HTML and CSS. So the methodology of the project is firstly the data collection, the data annotation, which I have collected 800 X-ray images from Istanbul Aydin University Dentistry Department, and we have also annotated them one by one. The second step was to apply image processing and then the YOLO V8 model. The image processing was actually in two steps. Firstly, resizing the images, as not all of the images is one size. So firstly, we applied a resizing, cutting from edges to have a fixed size of all the X-rays. And then the second step, to apply a Clache, which I will talk in details about. And the third step is the deployment to connect the user interface with the model itself. So here, the Clache image processing, or called contrast limited adaptive histogram equalization. If we can notice inside the red circle, we can see that before applying the Clache and after applying the Clache, the gray color is more light, which I applied this process before sending the image to the model, and this way the model can read better the image, which can enhance the accuracy of detecting. For training the model, I actually used the local machine, my local laptop, which took around 72 hours of training the model. I used also early stopping, which is a regularization technique in order to stop the model automatically if it does not function more, which I used actually 800 epochs, and the early stopping stopped after 572 epochs, and the best model was at the 561 epoch in the deep learning. The project architecture as seen here, it started firstly that the clinic or the doctor can send the image into the model itself, drag the image into the system. Then the image will go firstly through the image processing, resizing, then Clache, and then sending it to the deep learning model, get the detection, and send the image back to the user. The performance metrics of the models, I achieved 95.3% of mean average precision. However, it is noticeable that in the confidence curve, whenever we had more instances, which is basically more data collection, we had a better accuracy for each issue. So for example, we had the most data about extraction, and we can see the extraction is very high confidence. And this shows that if we have a huge data collection of the project, we can have a real world product. So the business side of the project, I imagine this can be, for example, sold as a monthly or yearly subscription for clinics, for example. And so the clinic can just immediately send the image to the system and get the result in seconds, which we can see steps from left to right, signing in, for example, sending the image and getting the result back. So how about the ethical perspective? One of the questions that might come to your head is the ethical consideration, how AI can really detect. And I would say that actually currently there are already some certifications, that is, there are some AI tools being used in the healthcare. And I would say in order to make this succeed as a real product, it needs a big data collection, firstly, and the quality of data, the quality of the annotation, which needs, of course, a team of healthcare professionalists. And one of the companies, actually leading companies in this sector, is PR, located in the USA, which is funded by the American Dental Association. They received the EU MDR certification for second opinion AI platform. For the future work, I would say the system needs a research, which can be estimated in 1 year more or less. But the most important is the team. It needs a team of dentists and healthcare professionals, and also data scientists, computer engineers, to collaborate together and have a huge data collection, annotation, and we can even develop another AI system with LLM, so the model can not just give a result of the diagnostic, but also can send a full report in a human language, and this can be a real second monitor for the doctor. So in the end, I would like to firstly thank my family, deep thanks to my family, my parents, who unlimitedly supported me, and without them I could have never done this. I want to thank Professor Dr. Rafit Agdeniz, Professor Dr. Dilara Arsalan, and Dr. Roa Mohammed Qasim for your support and engagement. And I want to thank also the radiologist Mohib Yildirim in the dentist department. She helped me in the annotation of the images. I want to thank all professors, teachers in Istanbul Aydin University, and also in Trento University in Italy, and the NJE University in Hungary during my exchange semesters. And I want to appreciate all the supporters and all friends who motivated me for this work. Thank you so much for listening, and I can show the test maybe after any questions if you have. Thank you so much.
Thank you.
Thanks and congrats.